Problem 3-23. Decide whether each of the following pairs of expressions are equivalent for all values of x, or a and b. If they are equivalent, show how you can be sure. If they are not, justify your reasoning completely. We're talking about equivalence here. So remember, equivalent means the same, or if you're talking about values, equal values. Okay, if you're talking about shapes, it'd be like the same shapes, almost like congruence. So what we're looking at here with these are just algebraic expressions. Letter A is asking us if the quantity of x plus 3 all squared is equivalent to x squared plus 9. If it is, then that means if we simplify this, it should look exactly like x squared plus 9. This is one that a lot of people make mistakes on because they get in the habit of wanting to distribute the 2 through the quantity. But if we look at it and what this exponent means, you have to remember that x plus 3, when you're squaring that quantity, it means the same thing as x plus 3 times the quantity of x plus 3. In which case, if we multiply these two together, you could use your generic rectangle or you could FOIL it. But regardless, either way, we could take it and you should end up with x squared. When we do x times our x, do our x times our 3, that'd be plus 3x. Do our 3 times our x here, and then that's going to be another 3x. And lastly, 3 times 3 is going to give us 9, so we have x squared plus 3x plus 3x plus 9. We go ahead and combine our like terms and we get x squared plus 6x plus 9. So when we compare that to our x squared plus 9, obviously those are different expressions. So we would say that these two are not equivalent. Now we could also check that by taking it and plugging in a value for x. If we wanted to plug in something like, I don't know, any value, really it should work if they are equivalent. But if we put in, just say like a 2, we would have 2 squared, which is 4. We'd have 6 times 2 is 12, so we'd have 4 plus 12 is 16, plus 9 would be 25. If we plug in 2 over here, we would have just 4 plus 9, which is 13, so we would know that those are not equivalent. Let's look at the next one. We have the quantity of x plus 4 squared, and we have x squared plus 8x plus 16. Now, based on what we've already learned this year, we know that when we multiply a binomial times itself, it should result in a perfect square trinomial. This is a perfect square trinomial, so we should come up with the same thing when we multiply it out. Just remember, x plus 4, when you're squaring the quantity, is the same thing as x plus 4 times x plus 4. We go through and we distribute this quantity through the second one, or FOIL it, however you wish to do it there. We should end up with x squared plus 8x plus 16. Over here, that's what we have, so we can conclude in this case that our two expressions that we're starting with are equivalent. If we plug in a value for x here, we should get the same thing that we would plug in over here. So these ones are equivalent. Sorry about the handwriting. It's been a while since I've used this. All right, let's scroll down here. Let's look at C and D. So letter C, we have the quantity of x plus 1 times the quantity of 2x minus 3. So we take it, we can multiply this out. We'd have x times 2x would give us 2x squared. We do x times negative 3 would give us negative 3x. We'd have positive 1 times 2x, which would give us a positive 2x. And positive 1 times negative 3 gives us a negative 3. We combine our like terms here, we're going to end up with 2x squared. A negative 3x and a positive 2x will leave us with a negative x. And then we've got a negative 3 here. You'll see here that's the same thing that we have in our other expression. So we can conclude that these two are going to be equivalent. Let's look at letter D. We have a parabola that looks like it's in vertex form, and then we have one that's in standard form. So if we wanted to check to see if these two were equivalent, we could simplify this expression. Another thing that we could do, though, remember, is we could graph it, and if we get the same parabola when we graph both of them, it should also be a way to determine if those are equivalent. So let's take this here. We've got to follow order of operations. We've got everything simplified in here first. X minus 4 is just x minus 4. So we're going to have to square that quantity first. So what we should have right now is 3. And when we do our x minus 4 times our x minus 4, we should end up with x squared minus 8x plus 16. And then we've got plus 2 afterwards still. Next, we wanted to distribute our 3 through the quantity. So 3 times x squared is going to give us 3x squared. 3 times negative 8 is going to give us negative 24x. And 3 times 16 should give us 48. And then don't forget to bring down the 2 at the end here. So this expression should be equivalent to this one, which is now equivalent to this one, and when we add our 48 and our 2, it should be equivalent to this one here. So we have 3x squared minus 24x plus 50. So yes, these two on D are going to be equivalent. Let's look at E now. E, we've got x to the third power, and we're taking that monomial and we're raising it to the fourth power. So remember just to think about what these exponents are really saying here. We're taking the expression x to the third and we're multiplying it times itself 4 times. So we really have x to the third times x to the third times x to the third times x to the third. Now, each of these would be like x times x times x, x times x times x, and all the way across there. So we're really taking our x's here and we're multiplying it times itself a total of 12 times. I'm just illustrating it all out here for anybody who may not understand where that's coming from. So let's see, I have my first x to the third, second x to the third, my third x to the third, and my fourth x to the third. Really though, the shortest way of writing that would be x to the 12th power. So is that the same thing as x to the 7th? It's definitely not. So this would then make these two expressions not equivalent. Remember, you could also take this and follow your rules for exponents too and do 4 times 3, which gets you your x to the 12th. All right, now on to letter F. We have ab squared, and then we have a squared, b squared. Well, this expression here is already simplified. This just simply means a times b times b. Over here, we actually have a times a, because that's what a squared is, times b times b. So between the two, these are not going to be equivalent when we look at what they actually contain within the expression. Now, one way we could also check this here is by putting in different values for a and b. If we said that a was, let's say, 2, and let's say b is 3, these two expressions should not give us the same thing. Let's see. This would be like saying 2 times 3 squared, or 2 times 3 times 3, which should give us 18. Over here, we would have 2 times 2, or 2 squared, and then we're multiplying that times 3 squared, or 3 times 3, in which case we'd have 4 times 3 is 12, 12 times 3 is 36, so it should have twice as much. Therefore, we can conclude that these are not equivalent. Now, the next question in the homework will discuss whether or not they are always equal or not. Okay, so sometimes you can have two expressions that are not equivalent but are equal, but we'll get to that in the next one there. So overall, when we look at these here, we have not equivalent for A, equivalent for B, C and D are both equivalent, and then E and F are both not equivalent. There are more ways to determine equivalence. Remember, you can also graph expressions and look at their graphs to see if they're the same, but we'll talk about those in other questions as well. All right, hope this helped you out. If you have additional questions, please make sure you ask your teacher in class.